Yeah, hello student. This is the fifth part of permutations and combinations, especially permutations. I started concept of permutations, NPR, n power r, and problem based on NPR and n power r. So NPR means from n distinct object selecting r and arranging r in a row. That is said to be NPR. The value of NPR is same as n factorial by n minus r factorial or n into n minus 1 and so on n minus r plus 1. So what is n power r? Here repetition not allowed, no, here repetition is allowed. If from an object you want to choose r and you want to arrange in a row, when repetition allowed, then the number of ways is nothing but n power r. Okay, so based on this we did some problems. So today also I am going to explain some problems based on linear permutations. Okay, so this is our first problem. Listen, interesting problem. If there are 30 railway stations on a railway line, how many number of single second class tickets must be printed so as to enable to a passenger to travel from one station to other? Okay, so first of all, students listen. Yeah, this is a 1 minute. Yeah, this assume that this is railway track. There are totally 30 railway stations. Say this is S1. I can say this S1 station, this S2 station, and so on. This is S30 station and this S29 station. Okay, so what is the meaning of the problem? Okay, how many number of single second class tickets must be printed so as enable to a passenger to travel from one station to other station, from one station to other station, not mentioned that from right to left or left to right, not mentioned, one station to another station. So for example, this is one of the ticket, and the ticket you can print as S1 to S2 you can print. What is the meaning of that? That person can travel from station 1 to station 2. Another ticket we can print as S2 to S1 arrow, S1 S2 arrow to S1. What is the meaning of that? A passenger can travel from S2 to S1. In another ticket we can print there like this, S1 to S10. What is the meaning of that? A person can travel from station 1 to station 10. Another ticket we can print like this, S10 to S1. A person can travel from station number 10 to station number 1. So such a way that how many tickets you can print, that is same as just like filling all these 30 station numbers into two blanks. Give same meaning, no? 30 station numbers into these two blanks. 30 numbers and two blanks. How many ways you can fill, Anna? 30 P2 ways you can fill. Means 32 P2 second class tickets you can print. Okay, that I will write. Final answer I will write here. Directly you can write. That is not a big problem. The number of what is the number of required tickets or something, required tickets. Okay, no, tickets equal to, directly I want to write 30 P2, don't confuse. Just S1, S2, S3, S30 should be filled into two blanks. Here I can write S10, I can write S1 or Sn, S like that. Okay. So by using fundamental principle of counting or product rule, directly you can say the answer, or by using linear permutation concept also you can say answer as 30 P2. So I don't want to simplify this, or you want, you can simplify, that is not a big problem. 29 3s are 9 3s are 27, 3 2s are 6 7 87, 870. Cross check, 9 3s are 27, 3 2s are 6 7 8. Okay, 870 tickets you can print. This is one problem. So another interesting problem, this is taken as important model. Okay, no, I don't want to read this problem. Something I want to explain here. Observe all of you. For example, A, B, C, D are 4 letters. So they will ask how many 4-letter words you can create by using ABCD. By using ABCD, how many 4 letter words you can create. Means I can say one of them is A B C D, another is A B D C, another is A C B D, another is A C D B, like that we will get. How many means just filling these 4 letter into 4 blanks, filling these 4 letter into 4 blanks. What you will get? Those many number of 4 digit numbers you can write. So 4 factorial. Means there are 4 factorial 4 letter words I can create by using the letters A comma B comma C comma D. Okay students, I hope you people understood. You write all like you get 4 factorial 24. One thing. So how many of this 4 factorial? How many of this 4 factorial started with A? Started with A. So what should do, Nana? You want to take A as a fixed place. A gone. Repetition not allowed. No. 3 blanks, 3 letters, 3 factorial ways you can arrange. Means there are 6 4 digited words. They are started with A. See 6 only. You write, you get 6 only. Okay. Sometimes what they will ask, how many words 4 digit words are there, so that A and B are come together. A and B are come together. How to solve this problem? This is interesting problem, students. A and B are come together. Actually, what happened here? We will get how many? Totally 24. No? From that, how many of them show that A and B come together? How to solve the problem? I will show you. Listen. A, B, C, D. This A and B is taken as one unit. They are always come together. One unit. And this is one unit, another unit, another unit. These 3 themselves you can arrange in 3 factorial ways. There exist 3 factorial 4 digit numbers, so that A and B are come together, that too A first, B second. I will write all those. I will write here A B C D, A B D C, C A B D, D A D B C. Okay students. Next D C A B, C D A B. 1, 2, 3, 4, 5, 6. These are 6. What is the question? A and B come together, that's all, but they not mentioned that A come first and B second. That is not given here. A and B come together, that's all. So what you got answer is 3 factorial. A and B come together, but A first and B second. Listen students, once again the question. How many 4 letter words you can create by using these letters, so that A and B come together? What should do? First of all, A and B taken as one unit, Nana. One unit. So C is one unit, D totally just like X, Y, Z. 3 different letters are there with us. X, Y, Z. How many ways themselves you can arrange? Themselves means 3 letters, 3 blanks. How many ways you can fill means themselves you can arrange? 3 factorial ways you can arrange. 3 factorial ways you can arrange. So I wrote 3 factorial. I wrote all the possible 3 words. These are the 3 factorial 6 words. But what is the important observation here? Among all these 6, A, B come together, but that too A and B, A first, B next. That is not mentioned. No, A and B come together means what happened? This will produce another linear permutation. I will write what is that with another color. B, A, C, D. This will produce another permutation. I am not changing the relative position of C and D, Nana. Just I want interchanging here. Here also B, A, D, C. So this gives another linear permutation. What is that, Nana? C, B, A, D. This is also gives D, B, A, C. This gives another linear permutation. What is that? D, C, B, A. Okay. So this gives another one. What is that? C, D, B, A. Totally how many? These 6, these 6. Totally 12 permutations we will get. Among these 12 permutations, A and B are come together. See, observe, A and B are come together only. A and B are come together. A and B are come together. A and B are come together. A and B are. Okay. But how to write answer? Simple word, no? That's why I wrote all. But how to logically how to write answer? I will explain. Listen, students. Listen, students. First of all, the question is A and B are come together. If A and B are come together means you want to take A and B as one unit. So remaining things are taken as separate units. 1, 1, 1. 3 units themselves you can arrange 3 factorial ways. One operation completed. Total problem is not completed. One operation complete. After completion of this operation, among all these 3 factorial, A and B is fixed. They have fixed position. That means A first to B second. That is not mentioned in the problem. That's why these two themselves change their places in 2 factorial. A, B themselves can change their places in 2 factorial. Means 2 letters, 2 blanks. Nana. How many ways you can fill? 2 factorial ways only. One is A, B and is B, A. Understood? That's why after completion of this operation, second operation, these two A and B themselves can arrange themselves in 2 factorial ways. So total operation from fundamental principle of counting, total required numbers are 3 factorial into 2 factorial, that is 6 into 2, that is equal to 12. Practically you got 12. Okay. Once again listen, this is important model. Now I am finalizing. Students listen, how many 4 letter words you can create so that A and B come together. A and B come together. So A and B taken as 1 unit, remaining separate units, totally 3 units, 3 factorial ways you can arrange themselves. Next, after completion of this, A and B, their places can change themselves in 2 factorial ways, because 2 digits themselves can change their place in 2 factorial ways. So second operation 2 factorial, totally operation is 3 factorial, 2 factorial, that is equal to 12. Means there are 12 4 letter words so that A and B come together. Okay. So they will ask another question. A and B never come together. Among the 4 letter word, A and B never come together. How? First of all, you want to arrange CD, Nana. First of all, you want to arrange CD. These two, after arranging CD, here we have one gap, here one gap, gap. 3 gaps are there for to fill 2 letters. There are 3 gaps to fill 2 letters. Here I can write 1 minute. Here I can write A, I can write B here. Or I can write B here, I can write A here. Or I can write A here, I can write B here. Or I can write B here, I can write A here. Like that. So what happened? Two letters are there to fill into 3 gaps. Don't confuse. 3P2 ways you can write. Some students will confuse. What I explained, in different digits are there, you need to choose R and you want to fill into R blanks. That is nothing. NPR blanks, blank means R. That is not correct. Don't think that R stands for always blank. That is not correct. 2 letters with the 3 blanks. How many ways you can fill? Just like these 3 X, Y, Z fill into 2 blanks. Both are give same meaning. I will show you, students, here. Don't confuse. I will show you. So what is the meaning of that? We want fill these 2 letters into 3 blanks. Don't think that that is 2P3. Wrong. Meaningless. 2 letters, 3 blanks. Can't write 2P3. We will write 3P2 only. I will show you. I will show you. Here, students, see. Yeah. CD, Nana. Okay. CD, 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 CD. 3P2 means what? 3 2s are 6. Okay. 1, 2, 3, 4, 5. Okay. Now I will show you. Here I can write A. Here I can write B. Here I can write B. Here I can write A. Here I can write A. Here I can write B. Here I can write B. I can write A. Okay, students. So what is next one? Anna? Here A I can write. Here B I can write. Here B I can write. Here A I can write. See how many you got? 1, 2, 3, 4, 5, 6. Among all 6 arrangements, A and B are not come together. See, A and B are not come together. Understood? How to solve the problem? No, listen once again. Practically, I wrote the solution. Anna. We got 6. But how to write steps and how to complete the problem? A and B are not come together. First of all, write remaining things. CD, write CD. After writing CD, we have 3 gaps between C and D. We want fill 3 gaps with these 2 letters. We want fill 3 gaps with 2 letters. I want write 3P2. Don't write 2P3. That is not correct. Sometimes gap may be more than the numbers. That is not big problem. Now these are taken as numbers and these A, B and T taken as gap. Okay. So we want fill A and B into 3 blanks. How many ways you can fill? 3P2. Okay. Among all these 3P2, CD fixed place. No? They can change their places also. So after arranging these 2 elements in these 3 blanks, 3P2 ways you can arrange. in these 3p2, CD place is fixed. C is here only, D is here only. C is left hand side of D. That is not mentioned. No? C may be right hand side of D also. That's why these two themselves can change their places in 2 factorial ways. So 3p2 into 2 factorial. 3p2 means 6. 2 factorial is equal to what is that? 3p2 value 6 only. So another 2, total 12 linear permutations we will get. But what you got here 6, no? Where is that 12 means? Here what happened among all these permutation, C left hand side of D, C is left hand side of D, C is left hand side of D, C left hand side of D. That is not correct. No. Here I can write D, here I can write C also. It means what? This will produce one linear permutation, this is another linear permutation. Here 6, here 6, totally 12. Okay. So students, important things, these are important model problems. So I hope you people understood. Okay, once again listen. A, B, C, D are 4 different letters. By using these 4 different words, how many 4 letter words can create means I can say 4 factorial. Among them, how many of them started with A means 3 factorial. How many of them are so that A and B are come together? A, B taken as one unit. So 1, 2, 3. These 3 themselves can have 3 factorial ways. Among all these 3 factorial, A is left hand side of B. That is not correct. A and B should come together. That's all. That's why A, B they can change their places in 2 factorial ways. So there are 3 factorial, 2 factorial linear permutations so that A and B are come together. Next one is A and B never come together. A and B never come together. What is the meaning of that? From total permutations you can subtract this. That also gives a meaning. From total permutations we need to remove the linear permutation which so that A and B are come together. Gives same meaning. A and B are never come together. So 24, no, 4 factorial minus what is this? 12. What we will get? 12 only. That only the answer, actual answer. Sometimes we need to use another way what I explained previously. So I will explain again that one. First of all, A and B never come together. So first of all take C and D and arrange them. In between C and D we have 3 blank places. These 3 blank places can be filled with 2 letters A and B in 3p2 ways. Okay, among all these 3p2, C, D are fixed, but C, D are not taken their fixed places. They can change their places. 2 letters no, themselves can change their place in 2 factorial ways. Therefore, required number of linear permutations is 3p2 into 2 factorial, that is 6 into 2, that is equal to 12. Okay, I hope you people understood now. Okay, now. Okay, now I want to complete this problem. Find the number of ways to arrange 5 boys and 5 girls in a row such that some conditions are given. Without conditions, I will explain first of all. How many boys? B1, B2, B3, B4, B5, G1, G2, G3, G4, G5. Without any restriction, these 5 plus 5, total 10 persons treated as objects. These 10 objects themselves you can arrange in 10 factorial ways. Understood? 10 objects you want to arrange in a row, Nana. How many ways you can arrange? 10 factorial ways. Means 10 objects you want to fill into 10 blanks. How many ways you can fill? 10p10. 10p10 means what? 10 factorial only, no? That's why this 5 boys and 5 girls themselves you can arrange in a row means how many ways you can arrange there? Means I can say directly 10 factorial. So that is not problem here. That is not problem. What is the problem? I will read now. Find the number of ways to arrange 5 boys and 5 girls in a row such that first one is all girls must sit together. Just like in previous example, A and B come together like that. All girls must sit together means all these girls are taken as one unit. Nana. 1, 2, 3, 4, 5, 6 units themselves create 6 factorial ways. In all the 6 factorial, one of the arrangement is this. Another arrangement also I will write. One of the arrangement B1, B2, B3, B4, B5, G1, G2, G3, G4, G5 and B5. What is that? B boys complete 1, 2, 3, 4. Yeah, I don't want right here. Here I want right B5. So this is one of the arrangement. This is one of the arrangement among the 6 factorial. What happened, Anna? What happened here? This is one of the arrangement, this is one of the arrangement, this is one of the arrangement, this is another arrangement. Identify the difference here. All girls come together only, but what is the thing? G1 after G2, G2 after G3, G3 after G4, G4 after G5. Not mentioned, no. The girls can change their places. So I can from this I can write one more thing. What I can write? G1, B1, B2, B3, B4, G2, G1, G3, G4, G5, B5. This is also one of the possible arrangement no here. What is the meaning of that? Girls also can change their places, but all should come together. That's why first of all what I did, Nana, all girls are taken as one unit. This boy is taken one unit. 1, 2, 3, 4, 5, 6. These 6 units themselves can arrange 6 factorial ways. In this 6 factorial, you will get 120 arrangements. Among 120 arrangements, this is one of the arrangement, this is another arrangement. This is not. This is one arrangement, this is another arrangement. Among all these 120 arrangements, G1, G2, G3, G4, G4, I have their fixed places like in this order only. But that is not mentioned in the problem. All sit together, that's all. Not mention that first girl first place, second girl second place, third girl third place, fourth girl fourth place, fifth girl fifth place, not mentioned. That means girls can change their places themselves. How many ways? 5 girls, 5 places. How many ways they can change their places? 5 factorial ways. Okay, so into 5 factorial. So total required permutation is 6 factorial into 5 factorial. This is the answer for the problem. What is the answer, Nana? the number of ways so that all girls come together is equal 6 factorial into 5 factorial. Students, I hope you people understood. What I did again I want to explain here only. So all girls is taken as one unit. 1 unit plus these 5 boys, single units, total 6. 6 objects we want to arrange in a row, 6 factorial ways you can arrange. Among all 6 factorial, the girls' position is fixed here. G1 after G2, G2 after G3, G4 after that. But the girls can change their places themselves in 5 factorial ways. 5 factorial ways into 5 factorial. Therefore, total number of required permutations is 6 factorial into 5 factorial. Okay. All girls come together means 5 factorial into 6 factorial. Sorry, 6 factorial, 5 both are same. Okay. Okay, listen. Total number of girls. Equal to 6. Boys equal to 6. All these are 6 or 5? 5. I wrote wrong. 5. All these 5 plus 5. 10 students or girls, okay, students I can write, students can sit in a row. In how many ways, Nana? In 10 factorial ways. Without restriction, no? Without restriction. A girl B1 after a girl 2 after a boy 3 after a girl 3 like that. No restriction. Themselves you can arrange 10 factorial ways. That is not mentioned in the problem. Just I wrote. Now I want complete problem number 1. What is that? All girls come together. All girls come together. Do one thing. How to write step, that is important. You write B1, B2, B3, B4, B5, G1, G2, G3, G4, G5. So all girls are taken as one unit. That is important thing. Okay, I will write that. All girls can be taken as one unit. So now we have 6 units. These can be arranged, arranged in a row. How many ways, Nana? 6 factorial ways. Okay, but girls can change their places in 5 factorial ways. So, required number of permutations is equal to 6 factorial into 5 factorial. Okay, I hope you people understood. No? First one completed. What is the answer? 6 factorial into 5 factorial. All girls are come together. How they will ask questions, that is important. All girls are come together. All girls are never come together. No two girls are come together. 3 type of problems. All girls are come together. All girls are never come together. No two girls are come together. Different, no, these two are different. Should take care of that. All girls are come together. Okay. All girls are never come together. All, two maybe, two will come, but all should not come. That's the second one. All girls should not come means all 5 girls should not sit together. 3 can sit, 4 can sit, but all 5 can't sit. That's a second problem. What is the third problem? No two girls come together. No two girls come together. I don't know why. The reason no two girls sit together. You can think why. Okay, leave it. Okay, no two girls can sit together. That is different. So I want to explain all the 3 situations. I already explained this. All girls are come together. All girls are never come together means total permutation means girls come together permutations. Total permutation 10 factorial. All girls come together is 6 factorial into 5 factorial. So 10 factorial minus 6 factorial 5 factorial gives all girls never come together. Okay. But how to find the answer for this? No two girls come together. That is interesting thing. Yeah. What happened? All girls sit together. No two girls sit together. I will explain. That is my third one. Okay. That is not mentioned. All girls never come together. I want to write that also. I want to write that. Just I will write. Note I will write. All girls never come together. Equal to 10 factorial minus 6 factorial into 5 factorial. Okay, leave it. So, what is our problem now? Next, I want to erase this portion. Okay. No two girls sit together. No two girls sit together. First of all, you want to arrange boys. Boy 1, boy 2, boy 3, boy 4, boy 5. Important thing is, this is not a fixed position of boys. They can change places. Here I can write B2, here I can write BY. Later I will explain that. First of all, assume that this is one of the position of the boys. One permutation. B1 here, B2 here, B3 here, B4 here, B5. Now, between these boys, we have 1, 2, 3, 4, 5, 6 blank places for 5 girls. 6 blank places for 5 girls. How many ways they can sit, Nana? How many ways you can arrange, Nana? 6p 5 ways you can arrange, no? Here 5 girls, 6 places. 6p5, don't think that 5p6, that is meaningless. From 6 only you can select 5, no? From 5, how can you select 6? Okay, understood? So, these 5 girls can sit in between these 6 places in 6p5 ways. This one operation completed. But among all these 6p5, B1 here only, B2 here only, B3 here only, B4 here only, B5 here only. The boys can change their places in 5 factorial ways. 5 boys, no, they can change their place in 5 factorial ways into 5 factorial. Therefore, the required answer is 6p5 into 5 factorial. No two girls sit together is 6p5 into 5 factorial. So, I will write that now. second one. Okay, first arrange boys. Okay, B1, B2, B3, B4, B5. 1, 2, 3, 4, 5, 6. I will write that. Now we have 6 places for 5 girls. Now we have 6 places between 5 boys for 5 girls. That is correct word. Now we have 6 places for 5 girls, or you can write now we have 6 places between the boys for 5 girls. We can arrange 5 girls in these 6 places in 6p5 ways. One operation completed. Now you among all 6p5 permutations, B1 here only, B2 here only. I will write here G1. Sorry, I want to use another color. For example, here G1, here G2, here G3, here G4, at last maybe G5. But this is one of the arrangement. Or here G5, here G1. Those are 6p5. What I wrote 2, no, those two are from 6p5. What is the important thing? Among all 6p5, B1 here only, B2 here only, B3 here only, B4 here only, B5 here only. The boys can change their places, no? You can write B2 here, you can write B1. That's why boys can change their places. After this, boys can change their places in 5 factorial ways. Therefore, the required number of permutations what is the meaning required permutation? No 2 girls sit together. No 2 girls sit together. That is equal to 6p5 into 5 factorial. Very, very, very interesting topic, interesting problem. Okay. No 2 girls come together. Completed. All girls come together. Completed. All girls never come together. Completed. No 2 girls. Difference. Identify the difference between no 2 girls come together. All girls never come together. In all girls never come together. 2 can come. 3 can come. But all should not. But here no 2 girls come together. Means between boys you want to arrange the girls places. Okay. I hope you people understood. Okay. So what is the answer? 6p5 into 5 factorial. Okay. Yeah. All boys sit together and all girls sit together. Interesting. All boys sit together, all girls sit together. Okay. Okay. B1, B2, B3, B4, B5. G1, G2, G3, G4, G5. All girls are sit together means this is taken as 1 unit. All boys are sit together means this is taken 1 unit. We have 2 units now. Themselves you can arrange 2 factorial ways. Left hand side all boys. First of all, left hand side of girls all boys. After right hand side of girls all boys. Only 2 factorial. But important thing is among all the 2 factorial, B1 here only, B2 here only, B3 here only, G1 here only, G2 here, their places can change. Boys can change their places in 5 factorial ways. Girls themselves can change their place in 5 factorial ways. So total operation is 2 factorial into 5 factorial into 5 factorial. Students, important model. What happened? First of all these boys is taken as 1 unit, all girls is taken as 1 unit. These 2 units themselves you can arrange in 2 factorial ways. Just practically you can say that this is one of them. 2 factorial, 2 only, no. This is one of them. Another one is here B1, B2, B3, B4, B5. But in these 2 factorial, what is the important thing? B1 here only, B2 here only, B3 here only, B4 here only, B5 here only. You can arrange, they can change their places. You can write here B2 here, you can write B1 also. That's why all boys themselves can arrange themselves in 5 factorial. All girls can change their places themselves in 5 factorial ways. Total operation is 2 factorial into 5 factorial into 5 factorial. Therefore, all girls and all boys sit together is answer is 2 factorial into 5 factorial into 5 factorial. But how to write step, that is important thing. So, all girls are taken as 1 unit, all boys are taken as 1 unit. These 2 units themselves can arrange in 2 factorial ways. Next step, boys can change their places themselves in 5 factorial ways, girls can change their places in 5 factorial ways. Therefore, the required number of permutations is equal to 2 factorial into 5 factorial into 5 factorial. Okay. No two of the same sex sit together, or boys and girls sit alternatively. This is another interesting thing. We need to identify the difference between this problem and second problem. In second problem, no two girls come together. No two girls come together. What is the difference in what is the difference between that and this? Boys and girls sit alternatively. So I will show you. Here B1, here B2, here B3, here B4, here B5. All boys. So I want to explain second one actually first. No two girls come together. So in between these 6 places, girls can sit. So I will show you. Here girl 1, here girl 2, here girl 3, here girl 4, here girl 5. This is one of the answer for second problem. This is not answer for the sixth problem. Why? Because see, boys are sit together only in this here. Before after B5, these 2 boys are sit together. What is the question? Boys and girls sit alternatively. What is the meaning of no 2 boys come together, no 2 girls come together? That is the meaning of the sixth problem. What is the meaning of second problem? No 2 girls come together. That's all. Boys will come together. 2 boys maybe come together. See here. Observe in this arrangement. No 2 girls come together. Observe here. But what happened? B4 and B5 sit together only. No. That's why. Please identify the difference between second problem and fourth problem. Okay. Boys and girls sit alternatively. Or no 2 of the same sex sit together. So this is not answer for the sixth problem. This is one of the answer for the second problem. So, but how to solve the problem? That is interesting thing. Listen, students, interesting problem, interesting chapter. Okay. So listen. First of all, I will arrange boys. Here I can write girl place. This is girl place. This is girl's place. This is girl place. This is girl place. What I am doing? I am not using here girl. That means the number of arrangements that started with boy only. That should started with boy only. Or number of permanent that started with girl. I will write that also. G B1, G B2, G B3, G B4, 1, 2, 3, 4, G B5. This is one of the arrangement. So I can write G1, G2, G3, G4, G5. These two are the answers for the sixth problem. Observe students. See, all boys and girls are sit alternatively. No? This is one of the answer for the problem. This is another problem. That's why to solve this problem, what I am doing, the number of permutations starting with B plus number of girls starting with B plus I am saying, observe all of you. The number of permutations or number of arrangement that boy can sit first. There may be chairs, no? Chair 1, chair 2, chair 3, up to 10 chairs are there. First chair is always allotted for a boy. Next case, I can say that the first chair is allotted for a girl. After that, I will add these 2. That gives the answer for the problem number 6. Okay. Number of arrangements that start with a boy. With boy, that's all. That boy means the boy may be B1 or B2 or B3 or B4 or B5, whatever it may. Start with the boy, that's all. So I will write B1, B2, B3, B4, B5. Start with the boy. Now how many places are there for girl? 1, 2, 3, 4, 5. 5 places, 5 girls. Themselves can arrange 5 factorial. Among a 5 factorial, B1 here only, B2 here only, B3 here only, B4 here only, B5 here only. Them there can change their places in 5 factorial. So 5 factorial into 5 factorial ways you can arrange so that boy can sit first. Similarly with girl also another 5 factorial into 5 factorial. total number of permutations 2 into 5 factorial into 5 factorial, like this. Okay, answer is that only, but don't think that always you will get same answer. So in this problem you are getting these two, getting same answers. Okay, what I can write, number of arrangements okay, sorry, arrangements that start with a boy, okay, equal to, directly I went, right, 5 factorial into 5 factorial. How you got, I explained. Next one, number of arrangements that start with a girl G1, G2, G3, G4, G5, now have 5 places for boys. So that is directly 100, 5 factorial into 5 factorial. At last, therefore, the required number of permutations equal to 2 times of 5 factorial into 5 factorial. Excellent problem, Nana. Okay, I hope you people understood.